not take up any more of his time.
Thank you very much for having me. So one of the reasons I was really excited to come here and talk a little bit about Scratch is I think that for many kids, Scratch is their first experience with the concept of open source software. And I'm going to kind of describe some of those aspects to you a little bit later on. But first, I'll just kind of give you a basic kind of introduction to Scratch and some of the ideas behind it. Why do kids need a programming language? Well, we felt like kids are bombarded by so much media today. It's like a giant fire hose. They got the TV, they have all the things on the internet that are aimed at them, but there's not that many opportunities for them to create their own media and then push it back outside into the world. So we wanted to make a tool that kids could be empowered to create animations, games, anything that they wanted to, and then share it with other kids online on the web. So this felt like something that was really important, and that was sort of the basic idea. The place that my group, the research group was coming from, was kindergarten. So we're called the Lifelong Kindergarten Group. And basically, we're called that because we think the way that learning works in kindergarten is actually pretty good. So in kindergarten, there might be a corner of the room where there's some blocks, and you can play with those blocks, and you can make anything that you want to. And maybe there's another corner of the room with some finger paints or some crayons, and you're encouraged to just go there and say, what do you want to make? Make it. Nobody's telling you really that there's a specific curricula of what you have to make. They're just giving you the tools and encouraging you to make stuff that you think is interesting. Now, we were also inspired by a lot of the work of Seymour Papert. And Seymour Papert had this idea that one of the most powerful ways to learn something is by being immersed in an environment where it's going on. So the metaphor that he used was, if you want to learn French, well, you can do it in a classroom and learn how to break the sentences apart and do all that sort of thing, but you can also just go to France. And by being immersed in the French language, you actually will learn it intuitively. You'll be sort of picking up all kinds of information just by being there. And so we wanted to create a tool that was similar to this, that worked with this philosophy and allowed people to be immersed and learn programming by doing it and being with it. Now, this is the way that I learned to program. This is Commodore 64. Anybody remember this old blue screen? All right, yeah. So as you can see, one of the things I've got right here already is a syntax error. And so if we think about this with that language metaphor, well, that's kind of harsh, right? So that's sort of like if I was trying to learn French and I went to France and I said, Je m'appelle Amos. As soon as I said something wrong, they would go, no, I'm not listening to you, syntax error. That's sort of tough, right? So we wanted to make it a little bit easier, a little bit more friendly in a sense, that you could go there and maybe somebody would say, well, try saying it this way. This is actually a piece of code that I committed to the Scratch website about 30 days ago and managed to entirely bring it down for an hour. Some of you who are developers, maybe you can look at this code and debug it. It took me a little while to figure out what I'd done. But it's very precise. Anything wrong with your code can have real bad repercussions on what it is you're making. And that might be okay for somebody like me with some experience programming. I go, oh, oops, I screwed up. I can do it again, right? But for somebody new, being that sort of keyed into any error, basically stopping the whole show, it can be really discouraging. And what we sometimes see is people start to create this identity of, I'm not a technical person. As soon as you say, hey, look, the computer, oh, I don't know about computers, they get really sort of scared. So we wanted to make a tool that would be more welcoming, more inviting. So this is Scratch, and I'll show you a little bit about how Scratch works. So Scratch right here, you have a sprite, and you have these blocks over there on the right-hand side. See, I told you it would be really small. That's why I invited you guys up to the front. Now, as I drag these blocks into here, different things happen. So now I have a block that moves and plays a drum, and I've snapped these two blocks together. See if I can get any sound out of here. And I'm changing the different drums that are played by the different blocks. And so, can you guys hear that through the mic, maybe? And now I'm going to wrap this in a control structure so it does a repeat. And now I have a dancing cat. So it's really, really easy to get started with Scratch. There's no possibility of any syntax error because you're dropping in these blocks. Of course, it might do something that you didn't expect, but there's no way to defend against that. And it might even be interesting. We find that a lot of accidental projects are cool. So I'll show you a couple of these Scratch projects. And first, I'll show you the cool Compiz little thing. Whoop. So this is a Scratch. Yeah, this is Linux, by the way. This is all open source presentation. Everything I'm showing you is all open source and free. In both senses of the word. So this is a program that we include with Scratch called Fish Chomp. And the way Fish Chomp works is basically there's a couple of lines of code over here. And all they do is they say point towards the mouse pointer. So when I start this, you'll see I'm controlling the big fish. And I'm going around here and I'm trying to get these little fish. And I can, every time I catch one, it makes a little sound and it says I've eaten it. So one of the ways that we might show a kid how to use variables is by not showing them how to use variables. Let's just wait until they want a variable. So one of the things that this project sort of lends itself to is that, hey, I want to know how many fish I've chomped. I want to know the score, right? And this has actually happened in workshops we give. They go, hey, wait, I want to make scores. Okay, so what we do is we go over here to the variables section, and I'll go over here and I'll make a variable, and I'm going to call it score. And now I have a little block over here, and there's a couple other blocks that are added, and there's one that says change score by 1. So I'm going to go drag that over here into this other script, and now every time you can see the score is displayed up there in the upper left side. Here, I'll make this a little bit bigger for a second. Every time I drag my little fish over there and catch one of these guys, oh, I knew I should have prepared better for this. There we go, 3. I got to practice my fish chomp. So every time I catch one of these fish, my score goes up, right? So it's not an abstraction. It's not just saying you need to know about variables because da-da-da, I said so. It's, hey, you can use this thing to do something that you probably would think is cool. See? Even hands off, I'm getting better. Yeah, I shouldn't count that one, I guess. So that's one example of an interesting Scratch project. Here's another one, and this one I'm actually going to, well, that's an interesting little effect here that didn't happen before, but we'll see how this works. This is a game that you all can play.
Let me ask you a question in reference to the previous slide. Now, what happens if they drag something over before time?
Over before time?
I mean, like they're dragging these blocks over. So what happens if they drag a block over before the program is set to function?
Oh, well, basically you can try out any block. As soon as you click it, it will actually do what the block says. So you can actually tinker around and just see what it does. And in this case, if you tried to execute the program without the block being part of a script that was being executed, then it wouldn't get run unless you clicked it again. But that's something you can learn pretty quickly. So this is a game. Can anybody figure out how this game works and how the fact is that all of you can play this game right now, simultaneously, right now? So get the bug then.
It's reacting to sound.
Yeah. So get the bug. Come on. Oh, nice. Louder. Hey, all right. Good job. Good. So this is one way that you can make interesting interactive projects with Scratch, right? So I'm taking the mic's input level, and as I make a sound here, I'm telling the bat to go down to whatever level the sound was. And that's, pretty exciting for kids. They get into that really, really quickly. Now, one of the nice things about, oops, I'm winning and I didn't even know it. So one of the nice things about this kind of program, if I can get over there, yeah, there we go, is that we wanted to make Scratch so it can import media from anywhere else on the web, because we wanted kids to be able to make projects based on media that they were interested in. So right now I have a bat right here, but I don't have to keep that bat costume. I can go over here and there's a costume and I can import something else, and any basic file will work. If I go to my desktop, let's see what I've got. There's also an entire library of different sprites that come with Scratch, so you're welcome to use those, but you can also, if kids know how to download images from the internet, that could work as well. And it looks like,
If kids know how to download it.
yeah, they don't know how to do this, right? So I'm going to choose a different image. Let's see, I guess I'll choose this little penguin right here. And look at that. So now I've just changed the Scratch project to work with the Linux penguin. And sort of a flightless bird, but nonetheless a bird, so it's close enough. So that's just an idea, but you could change that if you like Warrior Cats, if you like the Smurfs, if you like anything. All you have to do is you can take a project and change it so that the Smurf is the main character, and we see a lot of interesting situations where kids do that. So that's one of the sort of exciting aspects. So now, once you make that project, you can easily click a little command in the Scratch editor and upload your project to the web. And what this does is it puts your project on the Scratch website. And the Scratch website acts like a repository for everyone's Scratch projects, but it's also a community. So you can see each other's Scratch projects, but you can also comment on them You can give them love-its. You can add them to your favorites. You can sort of join into the conversation about the project. You can suggest improvements. You can do anything that you can do in comments. So that's been, we found to be a really important aspect of the success of Scratch, is that it's not just a tool for creating stuff. It's also a community to talk about stuff, to hang out and to get new ideas and think about new ways of creating projects. So I'll talk a little bit more about that stuff later. So I'll tell you the history of Scratch. So when we first started, we made this cool tool. We didn't really know how people were going to use it. But we were pretty pleased early on because, hey, right at the start, somebody made Donkey Kong in Scratch, right? And that, I think, is a sign of a legitimate programming language. If you can make Donkey Kong in it, it's real. So, so there's full-on Donkey Kong. I think it's a staple. But we also saw interesting other applications like this. This is a project that was made by a child in India who was studying the crust, the different layers of the Earth's crust. And he said, well, I can actually make a project to show all my friends how this works. So you can hear him kind of narrating. I'm trying to get the mic here. So he's describing, sorry about that, the different layers. And it even actually has the nice effect of when he hits the hydrosphere, the layer of water in the Earth, you'll hear a big splash. So this was something that we found really exciting. This was a new kind of application that we hadn't necessarily banked on, but we were very pleased to see it. So as we went on, we started to see some interesting social phenomena going on as well. So this was a project that was made by a 12-year-old girl from Russia, and she liked to make animated sprites. And so her idea was I could make a bunch of these animated sprites, share them in a Scratch project, and then anybody who wants to can take these sprites and use them in their projects. Because one of the cool things about the Scratch website is everything that you share, the source code is entirely available. So any project you find on the site, you can download and you can tweak it, you can remix it, you can do anything you want. So she started to kind of create this like repository of interesting, cool sprites. And then as she got more and more well-known, she began to get asked to do different kinds of jobs. So somebody said, hey, I really need a cheetah for my new game, and I don't really know how to make the animation. Can you help me? So what she did was she found an animated video of a cheetah. She figured out how it moves so that she could make a drawing based on the same kind of actual movement of a cheetah, and then she gave it to this person who had asked for help. So we actually ended up with somebody who was acting as a sort of spontaneous consultant in the Scratch community. And as she got more and more famous, people wanted to ask her for different kind of advice. How do you draw these awesome wings that you draw? So this is a project that shows you step by step how to draw a really cool and realistic bird wing.